Welcome back, students. So in today's lecture we are learning about Kirchhoff's laws. Okay, so in last lecture we have learned about the combination of the resistances in series and parallel, right? Okay, suppose if you know series and parallel combination, you can solve them. If you don't know combinations, then we use generally Kirchhoff's law to solve those circuits. Okay, yes, so generally Kirchhoff's law used to solve what complicated circuit which we cannot solve directly using like series parallel combinations. Okay, yes, okay. So Kirchhoff has two laws. So first is called KCL, Kirchhoff's current law, or you simply say first Kirchhoff's first law. Okay, Kirchhoff's first law, also called what? KCL, Kirchhoff's current law, also called node law, also called junction law, right? Many names are there, but all are same thing only. KCL I will talk always, Kirchhoff's current law. Okay, so this law already I taught in what? Thermodynamics, in heat transfer, and also we learn in fluid mechanics also, right now. Yes, so what this law says that already you learned that the sum of the all currents meeting at a junction is always what? Zero. Whatever the amount of current coming to a junction, same amount of current is leaving from that junction. Okay, so current coming in is what current going out. Still writing few words here. Let's write what this law there. This algebraic sum of all currents meeting at a junction is always zero. Sum of all the currents meeting at a junction is always zero. So any junction you take, like some junctions there where some wires are meeting, some current is coming like here, okay, I1 coming, I2 going, then I3 is going here, something, right? Then how you say for these junctions, you say the sum of the all current is what? Equal to always what? Zero. Sum of the all currents meeting at a junction is always zero, right? Okay, so also you can say that current coming in is current going out. What you can say, simple language, current coming in is what? Current going out. That's all. So like in this case, if you talk like this picture, then who is current coming in? You say that like I1 plus I2, these are coming in, is equal to what? Current going out. Or you can also write like that, coming like I1 plus I2 minus I3, you can say that what? Zero. Same thing only, right? Correct. Okay, 2 points you have to understand here. What 2 points? First, why this is happening, why the current coming in is what? Current going out, or the sum of the all currents is always zero, because this is law is based upon what? Conservation of charge. Charge, we know that fundamental property of charge, we have learned that charge cannot be created or destroyed, right? Only we can transfer charges, right? So what happens, whatever charge coming in to the junction, that charge should leave from the junction, because we cannot store charge at the junction, right now. So this law is based upon what? Conservation of charge. So this question was asked in our exam also. So Kirchhoff's first law, KCL, this law, okay, law is based on what? Conservation of what? Of charges. Yes, whatever charge coming in, that charge should leave from the junction, because we cannot store charge at that point. Okay, so charge coming in is what? Charge going out. Okay, same thing. Now this you understood is a very simple rule, and this rule already we have learned in thermodynamics. Remember, heat coming in, when rods are given, like 2-3 rods are combined at junction, then we apply Kirchhoff's law there also. Heat coming from some rods is equal to what? Heat going from other rod, right? So net heat at the junction, we say what? Zero. Heat coming in, like current coming in is what? Current going out. Same way, heat coming in is what? Heat going out. There we talk rate of flow, right? So hope you remember in thermodynamics you have done that dq by dt is equal to what? Del T by what? Thermal resistance. Same formula we write here, that formula we are writing here. Current is equal to what? Potential difference by what? Resistance. Exactly same similarity, right now. Here current is flowing, who is making current flow? Potential difference. Who is opposing current? Resistance, right? Electrical resistance. Same thing happening here. What flowing here? Heat is flowing. Who is making heat flow? Temperature difference. And who is opposing the heat? The thermal resistance, right? And same formula we have done in fluid also, right now. Pauli's theorem we remember? Yes, liquid is flowing, the rate of flow is given, then formula was something like pressure difference by what? Fluid resistance. Same formula did, rate of flow dV by dt in fluid is equal to what? Like pressure difference by what? RF, fluid resistance. Exactly same thing. Fluid was flowing, who is making fluid flow? Pressure difference. Who opposes fluid? What? Fluid resistance. Okay, same thing, all are similar. So these law we can apply here also. We did already, we solved questions like this there. Okay, so this law is based upon what? Conservation of the charges. Okay, yes. Now if you remember that in thermodynamics I taught you nicely with many help of many examples that how you apply this law. We understood that this law is there, that is sum of the all current between a junction is 0, but how you apply to numerical while solving numerical. So what we do, some branches will be given to you. We choose a branch, only one branch which has highest potential, like in this case, and here highest temperature, right? We have solved this question in thermodynamics already, you should know, okay? So we choose a branch which has highest potential in this chapter or in that chapter, highest temperature. We assume that like current is coming from that rod, that resistance, and coming to that junction, then what happens? We assume only one rod. So, okay, I am confusing actually between these two words, so I am talking now about this only, okay? Okay, let's focus on this. Once more, how you apply this rule, okay? Let me write here words so you understand better how to apply, okay? How to apply this rule when you solve the numericals. So it's very important. We choose, if we choose a branch which has what? Highest potential. Choose branch, okay, of highest potential. Yes, we choose only one branch. Okay, generally when they ask this question, direction of current is not given. Then if given direction, then it's simple. Current coming in like here, this picture I have given direction of current. So simply say that I1 and I2 are coming to the junction and I3 is leaving from junction, right? Okay, if direction of current is given, it's very easy. So you can do directly. When direction of current is not given, then what you will do, how you will apply this rule. So we choose the branch of what? Highest potential. Only one branch you choose. Then what you do? Assume that current comes to junction from that branch, okay? What are we assuming? We choose the branch which has highest potential among all given branches, 10 branch given, 5 branch given. We choose only one branch which has what? Highest potential. Suppose two branches has equal potential, then both we will choose, okay? So we choose the branch which has highest potential and we assume that current will come from that branch to the junction and goes in all remaining branches. And current goes in all remaining branches. Understand here? Suppose 10 branches are given. A junction is there and 10 branches are connected there. So we choose one branch which has highest potential. Right now, we assume that current coming from that branch and now goes in all remaining branches. Suppose 9 branches are remaining, so current will go in all what? 9 branches, right? What will happen? Sometime, like I said, in all 9 branches current is going, but it may be opposite of some branches, the current may be coming to the junction. That will come in answer. That will for that branch, the answer will come what? Negative. Okay. I will explain with help of example. Let's see this. So what we have to do? Choose the branch of highest potential. Assume that current comes from that branch to the junction and goes in all remaining branches, right? Simple. Okay. So let's see these things actually with help of example, okay? Okay. So how they have asked in an exam? Generally they ask simple question, they have asked like, so I am giving one example of simple question like say find I1 and I3, okay? So I am saying something like, okay, okay, this type of simple question has been asked first, okay? So look here, Here don't need to do any calculations, you have to solve step by step. This is saying find the I1 and I2 in this given loop right now. So look at this junction first. There are 2 junctions, 3 junctions, some junctions are given. Look at these junctions. 3 ampere is coming from that branch, correct? And I1 is coming here, right? And going is how much? 5 ampere. 3 coming here. How much should come here so that we get 5 ampere? So obviously you can say like 3 plus I1 for this junction. Let's call junction A, junction B and junction C. For junction A writing, you can understand this directly also. I'm just writing to understand, okay? Junction A. At this junction A, what happening? What are the currents coming in? 3 plus I1 coming, and going out is what? 5 ampere. So you say I1 is what? Simply what? Your 2 ampere. So obviously no need to calculations once you understand. So 3 plus 2, that should be what? 5 means this current should be what? 2 ampere, okay? Okay. 5 ampere current coming. Now talk about this junction, okay? Junction B or node B, right? 5 ampere is current coming, right? 1 ampere going here means how much current should go in this branch? Obviously what? 4 ampere, right? 5 ampere coming here, then how much going that branch? Going away 1 ampere. So remaining is what? 4 ampere should go in that branch. So at this junction, how much current coming? 4 ampere coming. How much going in this branch? 3 ampere. So how much should go in this branch? Obviously what? 1 ampere. Correct? Yes. So no need to write all these things. Just you say that your I3 will be what? 1 ampere. Hope you are understanding this. So this type of question they have asked in our exam. Yes. Very simple only. So now I do second type of questions where you have to apply these rules. Okay. Yeah. Okay. So let's say that find current, find junction potential and current through all branches. This is the question, okay? So some circuit will be given to you, open circuit generally, with some potential and resistances will be given to you. So watch carefully, this is circuit given to you, okay? And they are asking that find current in all branches, and branches name also can be given like some A, this is what B or something C, okay? Yes. Let's say this is D, okay? So they are asking find the junction potential. We have to find what is the potential at this point, and we have to find branch current in what? All branches, okay? So here I did not give the direction of the current. Like in this question they are easier, so direction of currents are given, you can do directly. So what we do here, we apply this rule. So understand this properly, okay? Yes. What we do, 3, 4, maximum they have asked for 3 branches only, but they can ask more, there is no problem. Okay, and exactly same question we have done in what? Thermodynamics also, okay? Heat is flowing, so, okay? Temperature will be given at this end, this end, this end, okay? That's all. Okay, so choose the branch of highest potential. 3 branches we have, 10 plus 10 volt, minus 5 volt and plus 20 volt. This has highest potential. So this is a branch where we assume that current comes in. So current is coming from this branch. Let's give some name I1 current, right? So current comes from the branch of highest potential and goes in all remaining branches. So let's say this branch current going is I2, and this branch you say current going is what? I3, right? Any one of these may be opposite also, like this I2 may be flowing in opposite direction, right? Maybe coming to a junction, that will come in answer. Suppose we calculate I2 and I2 comes negative, means current flowing what? In opposite direction, okay? I3 coming negative means this current is flowing what? Upward, that's all, okay? Yes. Suppose here we have one branch where 20 volt is given. Suppose this also given 20 volts, then both branches current will come in, right? Yes, if similar voltage given, highest voltage similar in 2 branches, then current will come from both branches and goes in all remaining branches. Okay, now what we will do is this, okay? So now we apply our Kirchhoff's first law. So apply the Kirchhoff's first law here. So how to look that I am writing here. So watch it. Okay, I can write it here to save space. So look here, sum of all current should be what? 0. Clear? It means current coming in is what? I1 should be equal to what? I2 plus what? I3. Correct only? Current coming in is what? I1. Current going is what? I2 and I3. Now what are these values? Let's put the values of this. How will put value? What is current I1? What is current in this branch? Potential difference across this branch by resistance. What is the potential difference? 20 volt, and this volt is unknown. So 20 minus potential is what? 20 V, right? Now this is a potential difference across this branch, right? AD branch or this branch. Resistance is what? 10 ohm is equal to, right? I2. What is I2 here? Look here, current flowing this direction means this potential is what? High always, right? So what is potential difference across this? Watch, V minus 10 by what? 10. So people do mistake here, they write like, I want to write the current in this branch, they write like 10 minus V naught. We assume that current coming from this branch and going on all branches means this potential is what? More than these all potentials, okay? We have assumed like that. So current flowing that direction means this potential is what? High. Current always flow like from high potential to low potential, right now. So this potential V is more than what? 10, V is more than what? That minus 5. So this minus that, right? Be careful. Okay, plus I3 means this V minus 5 means become V plus 5 by resistance what? 5. Okay, we have to simplify this. So what we will do, we multiply by 10 to cancel this. Okay, so I am multiplying by 10. When you multiply by 10 you get 20 minus V here is equal to here V minus 10, right, and plus here we are multiplying by 10, so this becomes 2V plus what? 10, correct? Yes, I have simplified this. So let's find, we have here minus 10, this term get cancelled, right? Okay, so what is remaining? 20 only, and this V goes other side, minus V plus V, this become what? 4V. Okay, so your V coming what? You say 5 volt. So your junction potential means the potential at this point is how much volt? 5 volt. Clear? Yes. So now watch carefully. If you see, this is 5 volt, this is 10 volt, means the direction of current here should be what? Opposite. That will come in answer. Let's check it. So question what they are asking, find the junction potential. That's your answer done, correct only. Now find the what is saying, current through all branches. Okay, now we have to find current. Okay, let's find current. What is current? I1 is what? That we wrote I1, right? 20 minus V. So 20 minus V means what? Okay, let me write here by resistance 10. So 20 minus 5 by what? 10, that becomes 15 by 10 means what? 1.5 ampere, correct? Okay, what is I2 current? So I2 means that's what your I2, right here. So that's V minus 10 by what? 10. V we have calculated 5 minus 10 by 10, you're getting minus 5 by 10 means minus 0.5 ampere. Now this is important. Here we got answer negative. Negative answer means this current is not flowing this direction, this current is flowing what? In that direction. First thing, direction you have to reverse, right? Yes, you have to reverse. Okay, see, same way now I3 is what? I3 V plus 5 by what? 5. V is 5 plus 5 by 5, that's also 10 by 5 means what? 2 amperes. Now look here, other things are nothing you have to change actually. Okay, your potential and everything is are correct only. Okay, just answer coming negative means direction is what? Opposite. Now watch carefully, current coming from this side, how much? I1 coming 1.5, this current coming how much? 0.5. Addition of these to become what? 2 ampere. Yes, 2 ampere is flowing through this branch. Yes, see there. So this is correct only. Okay, nothing you have to change. Negative answer coming for current means what? Direction of current is opposite, that's all. Okay, calculations are not wrong. Okay. Okay, let's see one more example here. Okay, similar example will do. Suppose this. Question remains same, that find the junction potential and current through the branches. Okay, yes. Okay, so these are branches given and we have to find here junction potential. So this is grounded, that's minus 10 volt and this what? Plus 10 volt. Clear? Obviously, I will start the calculation. You say that who has highest potential? This branch, plus 10, minus 10 and 0. So current will come here, let's give name I1 and goes in what? I2 here and goes what? I3 what here, right? Then you say that I1 should be equal to what? I2 plus what? I3. Okay, now you write what is current? Potential difference by resistance. So what is I1 potential difference here means 10 minus V by resistance is what 5 is equal to what is I2, this current potential difference means V minus 10 means what plus 10, V minus 10 potential difference we writing by resistance 10 plus V, this is what 0, so V only by what 10, correct. Okay, multiply this whole equation by what 10. Okay, so 10 multiply get 20 minus 2V is equal to what V plus 10 plus what V. Okay, so this 10 goes the other side becomes 10, 2V goes the other side, 2V plus V become what 4V. So V becoming what 2.5 volt. So watch carefully, what is the potential coming junction potential 2.5 volt. Now when you see direction of current, watch carefully, what is I1 direction, what is I1 current, that's your I1, 10 minus V by 5, 10 minus V already calculated 2.5 by 5, this becomes 7.5 by 5, so this becomes around 1.5 ampere, done. Yes, okay, then look at this current I2 is what, I2 is this one, V plus 10 by what, by 10, okay, this is what 10, so watch carefully. So V is 2.5, so it becomes 12.5 by 10 means what 1.25 ampere. And last current is what, I3 is what, V by what 10. So V is how much? What is V? 2.5 by what 10. So that becomes 0.25 ampere. So you can cross check now. I1 should be equal to what, I2. All are coming positive means all directions are okay, no problem. Okay. So I1 should be equal to what, I2 plus I3. I1 is coming 1.5. So look here, 1.25 plus 2.25 is what, 1.5, right? Okay. So this is what your Kirchhoff's first law, okay, which is very simple. So what is the main thing here you have to do? You remember this trick, okay. You choose a branch of highest potential current, come in from that branch and goes in all remaining branches. If two branches have highest potential equal, then from both branches current will come in and goes in all remaining branches, right? Same rule we write for thermodynamics also, and very important question in what, heat flow, right now. Yes, okay. So now we will do what, second law. Okay, so now we are doing this Kirchhoff's second law. So you can call it second law simply, Kirchhoff's second law, also called KVL, Kirchhoff's voltage law. Also you call it what, loop law, right now. Yes, because this we apply to a closed law. Listen, the first law, Kirchhoff's first law, you apply to what, a junction. That junction may be in open loop or in closed loop also, but this law apply only to a closed loop. So let me write first, this is applicable, okay, to only what, closed loops. If you have closed loop, then only you can apply this law, right? And this law says what? It says that the sum of the all voltage drop in a closed loops, sum of the all potential drop in a loop is always what, 0. Let me write, then I will explain you. This says that, or you say the algebraic sum of all potential drop across a closed loop should be what, 0. The total voltage drop in a closed loop is always what, 0 only, right? Yes. If you see actually in any circuit, electric circuit, we have just two elements, what, a resistance and a battery or cell, right now. So the total voltage drop across this battery and what, your resistance should be what, 0 in a closed loop, any closed loop, right? Okay, if you give attention, the first law, Kirchhoff's first law, was based upon conservation of what, charge, right? So this law is based upon what, conservation of what, energy. This law is based on conservation of energy, right? You start from one point, you go across a loop and come back to same point, means you are at same point, so energy should be what, same. So change in energy should be what, 0, change in potential should be what, 0. Okay, change in potential 0 means energy also 0. So means energy remains what, conserved here, okay. Okay, so second law is based upon what? Conservation of what? Energy simply. Okay. Now, this you understood. So what you say mathematically? You say that the net voltage drop in a closed loop should be what? 0. Or you can say that we have just two elements. So one we have battery. So net EMF of the battery plus net voltage drop across resistance, that's called IR. This should be equal to what? 0. Just two element only we have. Okay. A battery and a resistance. So net voltage drop in any closed loop is always what? 0. Right. Now how to apply this law? Okay, this law. How to apply? When you're solving questions, how to apply? Like first law. How you applied first law? You choose a branch of highest potential current come from that branch and goes in all remaining branches, right? If anything is opposite, the answer will come what? Negative simply. Okay. Yes. So how to apply this? You choose any loop where you want to find something unknown, like current unknown or some resistance unknown or a battery unknown. You apply Kirchhoff law. You start from any point, you go across the complete loop and come back to the same point. You can go in clockwise direction, you can go in anti-clockwise direction, it doesn't matter. But suppose you're writing for two loops, okay? In one loop you're going clockwise, then next loop also you have to go clockwise, okay? Same direction you have to follow for any loop, okay? So what you do, start from any point in a loop, okay? Then what you do, go, you clockwise you can go or you can go anti-clockwise also, no problem, right? In loop and write what? Potential drop across all elements, right now. Correct. And you write what? Net potential drop, and then what you say that this net potential drop should be all equal to what? 0. Something will be unknown, that unknown you can find with the help of this law, right now. Okay, so when we do here, actually we have to follow some sign convention rule, like the voltage drop is what? Positive or negative. Okay, so you're talking about sign convention. So see here, voltage drop, you're writing that voltage drop should be positive, negative as a rule. So just we have two element, what? Battery and resistance. Okay, so let's talk about what's your cell or your battery. Okay, correct. Suppose you have battery, this is your battery, right? Negative terminal, positive terminal, okay, of EMF what? E, correct. Suppose you're going in a circuit and you're jumping like this way, you're going negative terminal to positive terminal of the battery, then your potential will increase. So your voltage drop will be what? Your positive volt, like 10 volt battery given, then voltage drop you write as plus 10 in your calculations, right? If you're jumping from negative terminal to what? Positive terminal. Or you do it opposite, you go like that way, you're jumping from positive terminal to negative terminal, then your voltage drop will be what? Minus E. Simple rule. Yes. Also this sign convention, like potential drop, you say voltage drop does not depends on what? Direction of current. In battery, your voltage drop will not depends on direction of current, how current is flowing, like in this circuit current is flowing this way or flowing opposite, this answer will be same. It depends only how you are jumping from negative to positive terminal or positive to negative terminal. Negative to positive means your potential is increasing, so answer is what? Plus E, or positive to negative means your voltage will decreasing, so negative E, right? Does not depends on direction of current. This depends on direction of current in case of what? Resistance. Okay, let's write for resistance now. So you're writing sign convention for resistance. What will happen? Look here, this is a resistance, correct? Suppose current is flowing this direction, depends on direction of current, so current your direction you have to write, this is your current I flowing through this resistance. Suppose you going this way, so you call along direction of current, right? Along direction of what? Current. Suppose you are in your loop, you are going like this way, direction of current. You are following direction of current in a resistance, then your voltage will decrease. Okay, so your voltage drop here is called what? Minus IR. Your voltage drop across this resistance will be current into resistance, and that's what? Negative. Or by chance you go like this way, you are going against the current, right? Against the direction of what? Current. If you go like this, then your potential will increase in this resistance. So what is voltage drop here? Plus IR. These are the two simple rules to understand what sign convention. Okay, a battery does not depends on direction of current, depends just how you're jumping, negative to positive terminal or positive to negative terminal. But in case of resistance, it depends on direction of current. Like I have chosen that direction right now. Okay, then if you go in this direction, along the direction of current, your drop is called negative. You go against the current, your drop is called what? Positive. Simple. Okay. Okay. So let's see with the help of example how to understand this, how to apply these rules. Okay. So let's see some questions. Question number 1. Okay. Now watch carefully. So some circuit is given and something they're saying like this is point A, this is point B. And the question is they find the potential difference between point A and B. Either they will ask you potential difference between 2 points, or potential at any one point is given, they will ask you potential at some other point. Okay, yes. So let's see first this question. So this question is simple, one loop. You can solve by directly also by writing the resistance, series and parallel that rules, or you can write this. I will do by both rules. Suppose directly you want to solve this without applying this Kirchhoff's law, then how you will apply it? Okay. First thing is we have to find the current in this circuit. You want to find potential between point A and point B. So first you have to find what is the current in this loop, because current is unknown, all things are given to you, batteries and resistances are given. So let's write any direction of current. How you will write? Look here, this is plus 15 battery and this is opposite, this is what same direction. So look here, plus 5 plus 15, they will produce current in what? Like clockwise direction. This will produce what? Anti-clockwise. So these batteries are powerful, bigger than this. Okay, so we assume the direction of current will be obviously like that way, clockwise, right? Sometime direction of current will be given, sometime you have to write by yourself. Okay. Okay, this is direction of current, clockwise flowing. Why? Because plus 15 and plus 5, these are what? Producing clockwise, plus 10, this battery producing what? Anti-clockwise. Okay, so these batteries are bigger. Okay, suppose look here, directly I am doing. Okay, what is the net resistance? Net resistance is what? All are in series, one closed loop, 5 ohm, 10 ohm, 10 ohm, 5 ohm. What is the net resistance? 5 plus 10 plus 5 plus 10. What is the answer? 30 ohm. Net EMF, what is the net potential of the batteries? Plus 15 volt plus 5 volt in this direction and minus 10 volt, right? So 15 plus 5 minus 10, what is the answer? What here? So this become what? How much volt? 10 volt, right? Correct, net 10. So what is the current flowing the circuit? Net current 10 by what? 30. What is the answer? 1 by 3 ampere. This is your net current flowing. Done? Okay. Now this answer you can also find directly by writing Kirchhoff's law. Okay? Yes. So let's write Kirchhoff's law. Same answer you can want to get. You wrote like 3 steps. You found net resistance, net EMF, then you found what? Current. So loop, you have, suppose you want to apply loop here. In this you want to apply Kirchhoff's law. Okay? So I am applying here KVL and I want to get same answer. This I did directly. Okay? Simple, one closed loop, then you can do directly. Suppose there was another branch here, then you cannot do like this one. Okay, it will become complicated. For simple loop you can do like this well. So now apply KVL. Suppose you start from any point, you can start from any point in this loop, doesn't matter how you starting and how you going, clockwise or anti-clockwise, doesn't matter at all. Okay, so okay, suppose I want to start from point A and I am going clockwise in this loop. Okay, so I am writing, you can start from any point, doesn't matter at all. You can go in any direction, clockwise or anti-clockwise, doesn't matter, answer will be same. Suppose for understanding, I am starting from point A to understand this. Okay, you start from this point, I am going how much? I am going clockwise. Okay, clockwise I am going, you can go anti-clockwise, so you should get the same answer. You start from here, let's go clockwise, nobody is here. Then first you go to this battery, correct? So battery is jumping from positive terminal to negative terminal, positive to negative, sorry, yes, positive to negative, right? Where is jumping? Here, positive to negative means what? Your drop is called minus 10 volt, negative. It's going here, jumping from positive terminal to negative terminal, voltage drop is what? Minus 10. Then you got this resistance, you going direction of the current, you going direction of current, drop is called negative, minus IR. So minus I means we calculated 1 by 3, R means how much? What? 10. Okay, so done. Sorry, we calculating current actually. Okay, 1 second. So minus 10 into what? I. Current is unknown, we have to find I current. Then we got this battery jumping from negative to what? Positive terminal. So plus 5 volt. Okay, negative to positive. Then we got this resistance, again voltage drop is minus 5 into R, I into R, right? We going direction of the current. Okay, Then we came here B point, then coming here we got another resistance, so minus 5 into I, because you're going again direction of current only, and we got this battery jumping from minus to what, plus terminal, so voltage drop is what, increasing 15 volt. Then we got this resistance, so minus 10 into I, because you're going direction of current only, all this equal to what, 0. So let's calculate how much, minus 10 minus 50 15 minus 20 minus 30 30 I is equal to minus 10, okay, minus 10, and this is what, plus 15 plus 20, so minus 10 goes what, 10, so I is coming what, again 1 by 3 ampere. So this current you can do directly, you can apply KVL. So directly you will do when there is only one closed loop, that's all, right? Okay, now main question was here that find the potential difference between point 1 and what, point A and point B. So what you will do now, you start from point A and go to point B, find the net voltage drop, that's what your answer. So also potential is what, is scalar quantity. Potential does not depends on your path. You going from one point to other point, you can go any path, potential difference will be same, does not depends path. So you want to find potential difference between these 2 points, you can go by this path, that's path number 1, or you can go by this path, path number 2, you should get exactly same answer. Okay, let's check both path. Suppose you follow path 1, you start from this point and go toward B point by top path, this branch, you should get the some answer. Let's check. So starting from point A, how you write? You write like VA. Suppose potential at point A is what, VA. Okay, then you got what, this battery. Here answer we gave, positive answer came, means direction of current is correct only. Suppose here answer come negative, means direction of current is flowing what, in opposite direction. First you have to write direction of current properly. Okay, positive answer means whatever you assume, that direction is correct only. Okay, potential at point A is, let's call VA. Then you got this battery minus 10 volt, right, jumping positive negative. Then we got this resistance, we going direction of current, so minus 10 into current now we know is what, 1 by 3. Okay, here then we got this battery plus 5, right, then we got this resistance minus 5 into what, 1 by 3 is equal to what, last point where you want to find point VB. Like this you have to write, starting from that point is equal to the last point. Now you want to find potential difference, so you say VA minus VB, this you want to find is equal to what, 10 minus 10 and plus 5 is what, minus 5, so other side become plus 5, 10 by 3 plus 5 by 3, so 5 by this become 15 by what, 3, this becomes what, 10 volt. So how much potential difference coming between these 2 points, point A and point B, 10 volt. Sometimes the potential at any point is given to you. They said potential at B point is what, 0. You can put 0. Then they will ask you what is potential at point A. Okay, you can find VA, right? Okay. What I'm saying, I went by this path. You can go by this path. You should get exactly same answer. Let's try second path. So I write here path 2. You should get exactly same answer. So start from point A and go to point B by lower path. Look here, VA. Okay, this potential at point A. Then you got 10 ohm and you're going now against the current. Current is flowing like that way, right? Now you're going against the current, so drop is called positive. 10 into what, 1 by 3 IR. Battery, you jumping positive negative terminal, so voltage drop is called minus 50. Then you got this resistance, you going against the current, so 5 into what, 1 by 3, all equal to what, VB, no other body between them, right? So you want to find VA minus VB. So look here, what you got, minus 15 goes outside, become plus 15 minus 10 by 3 minus 5 by 3. So you got 15 minus 15 by what, 3, 15 minus 5, that's become what, 10 volt. We got 10 volt answer here, we got 10 volt answer here. So understand very important thing, that potential difference you're finding, it doesn't depend upon which path you're going right now. Suppose another branch was here, something like this, okay, between them, right? Now you have more path to go from A to B, like you can go here, here and here, right? You can go like this path also, you should get exactly same answer. You can start like here, go here, go here, go here, that also. Any path you follow, your potential difference will be exactly same, because potential is a state function, does not depends on what path you're following, right? Okay, hope you understood something here. If you're not understood, I'm doing more example, because it's very important from exam point of view. So let's discuss some more example. Okay, for few more questions we have here. Let's do them based on Kirchhoff's second law. So look at this question. Find the potential difference between C and D branch for the given circuit. So one circuit is given and direction of current is not given, so we have to write by ourselves. So two batteries are given, 10 volt and 12 volt. So assume that current start from this battery, big battery, let's call current I. So in this loop current flowing is what? I, right? Then current comes here, some current will go in this branch, remaining will go here. Suppose in this branch you call it I1. Then how much current goes in that branch? Obviously I minus what? I1. So this I minus I1 is flowing this whole circuit, coming here, this I1 coming, and here again current becomes what? I. Always try to write minimum number of the unknown things. So current started from the 12 volt battery is what? I. Some current going here I1, you can write here also I1, then you can write I minus I1, that doesn't matter, okay, anywhere you write. Now, so first we have to find these currents to find the potential difference, okay. Resistances are known, batteries are known. So now we have to write what? Loops here. So give attention, this is important. So here what we do, we have two loop, one loop this, one loop this, or one you can talk the big loop also, okay. So at least because I and I1, these are two unknowns, so you write two loops, okay. So let's write two loops. This is a loop number what? 1. Loop number 1, this is a loop number what? 2. You can go clockwise, you can go anti-clockwise, your choice, okay. So start from any point, let's start from this point. I'm starting from this point, I'm going this loop clockwise. Let's write net potential drop. So I'm writing loop 1. Look what is the equation. I'm starting from here. First I got this battery, I'm going positive to negative terminal, so minus 10 volt. Okay, I came here, then I'm going here downward. I'm going in 4 ohm resistance, current is I1, and I'm going direction of current, so minus 4 times I1, right? Okay, I came here till, now I'm going here. Okay, I'm going now upward, so I'm going against the current in this 2 ohm resistance. So answer is plus 2 I minus I1 is equal to what? 0. So net voltage drop in your first loop. You can start from any point and come back to what? Same point. Okay, so you can simplify this. Look here, this is what? 2I, and this becomes minus 2I1, and 6I1 minus 6I1 is equal to what? 10. This is the equation 1. Okay, let's write loop 2. You want to write same equation for loop 2. Here you went clockwise, so here also you have to go clockwise, but you can start from any point, doesn't matter. Let's start from this point, okay. You go here, come like this, okay. So starting from here, first you got this battery, so you got minus 12, okay. Yes, you're jumping positive to negative terminal, voltage drop is called negative. Then you got this resistance, current is flowing here upward, right. You're going what? Against the current, downward you're going. So plus 8 into I. What is current in this resistance? I, right? You're going downwards, so your drop is called positive IR, okay. Okay, you came here, then you came here, no one is here, now you're going what? Upward here, right, in this branch. So you're going against the current, plus 4I1 all equal to what? 0. Okay, arrange it like that format. So we got 8I plus 4I1 is equal to 12. This is second equation. So you have to simplify these two equations and get our answer unknown. Unknown are what? I and I1, okay. That's fine. So what is simple way? In this equation I multiply by 4 and put it down here, this equation. So I'm putting here multiply by 4 means become what? 8I minus 24I1 40. Correct only? I have multiplied this equation by 4. So this 4 into 2, 8, 24. Yes, and what? 40, okay. So let's simplify them. Subtract, add, subtract. This goes zeros, okay. 4 plus 24 means 28I1 here is equal to, here we have 12 minus 40. 12 minus 40 is how much? So 28 and is minus 28, keep in mind, okay. What? Minus 28. So I1 is coming what? Minus 1 ampere. So focus here. First we got negative. Magnitude is 1 ampere, but negative means I1. What direction of I1 we are writing here? Like this one, downward. So this current is not flowing downward, right? So immediately you have to change now. After you find the answer here, you have to change the direction of current here. I assume that is flowing downward. No, this current is flowing what? In upward. That's the meaning. So you have to correct in the circuit now, okay? Yes. Okay, current you found. Then you need what? I, main current. So let's write main current. From any equation you can write. Let's write this equation. So 2 times of I1 is minus 1, minus become plus 6 is equal to what? 10, 2I is equal to what? 4, and I is equal to what? 2 ampere. Correct? Yes. So I current positive only coming, is direction of current I is correct only how much? Value 2 ampere. Okay, this is done. Okay, so if you need, you can find the current in that branch also, I minus I1, 2. And now look here, we have corrected direction here, so that should be what, 1 ampere now. 2 ampere coming from this branch, keep in mind, and 1 ampere is coming from this branch, 1 ampere. So what is current here? 3 ampere. We give pen, okay? This is all current. Okay, now watch carefully. We have to find potential difference between C and D point. Okay, so this is C and D branch. Okay, C point here, D point here. You can follow any path and you will find the correct answer. Simplest path is what, you go like this and you come what here, because you see only one resistance. So I am starting from C point, so VC, right? Nobody is here, nobody is here, then this resistance alone. So I am going directional current minus, what is the current here in this branch? I means how much? 2 ampere, and resistance is what, 8, is equal to what, D. So VC minus VD is what, 16 volt. Now you go any path, you should get exactly same answer. We will try one more path. Suppose you go from this path here, then you here, right? So you start from VC, then you went here going direction of current, so minus 4 into 1, so 4 only. Then you came here, this is a battery. How much battery? Minus 12 is equal to what, VD. So VC minus VD is again what, 16 volt. Any path you go, answer will be what, same, because potential difference doesn't depend on your path. Okay, this one question. Okay, let's see this question. Find the current in the branch BD. B and D, in this branch they are asking current, right? Okay, so what we do, let's again see two batteries are given, 15 volt, 45 volt. Obviously this is a big battery. Let's start current, start I here. Okay, so in this, what is current flowing? I. Current comes I here, then see two branches, that branch, this branch let's call current I1, then that branch will be obviously I minus what, I1. Okay, so that current is flowing here, again coming here, and the meeting here, make what, I current. So again same thing, you have to write two loops to solve, find these currents. So this is loop 1, that's loop what, 2. You go clockwise, you go anti-clockwise, your choice. So okay, this is done. Loop 1 I am talking, I am starting from this point, go here and come back to what, the same point, right? Okay, first I got 6 ohm resistance and current flowing what, that way. I am going against the current, so 6 into what, I minus I1, positive. IR is what, positive here. Then I am going this resistance, I am going direction of current, so minus 3 ohm into what, I1. Then I came here, I am going here, so plus 15, all equal to what, 0. Correct? Okay, so let's simplify this. You got 6I minus 6I minus, so minus 9I, okay, is equal to what, minus 15. This is equation 1. Okay, let's write second loop, loop 2. Where is loop 2? This loop. Start from any point. Let's start from B point, go here and come back here, right? First we got this 6 ohm and current is coming like that way, going against the current, so we got 6I. Okay, then we got this battery, so that will be minus 45, we go jumping from positive to negative terminal. Okay, we came here, now we're going against in this branch, so plus 3I1 all equal to what, 0. So what is the answer here? 6I plus 3I1 is equal to 45. This is equation number 2. Okay, simply you can add these two equations. So that equation I am putting here down, 6I minus 9I1 is equal to minus 15, minus plus this goes, this becomes 12I1, 45 plus 15, that becomes 60. Okay, yes, so I1 you have calculated, I became 5 ampere and is coming positive this time, means whatever direction we assume, that direction is correct only. Okay, I1 we have found, so let's find I from this equation. Okay, look here, 6I minus, this become, sorry I am writing a little wrong, this is what, I1, right? Yes, correct only. So I1 we found, 9 into 5 is what, 45 is equal to what, minus 15, 6I. Okay, 45 will come on this side, so minus 15 plus 45 is what, plus 30. So I becomes what, also 5 ampere is coming, same or I did some calculation mistake. Let's check once more. Hope I not did anything wrong. Still let's check it. So 5 ampere, 45 comes here, 30 only coming, same. I also coming Okay, it may come, doesn't matter. So I think correct only. If anything wrong, please you check it and tell me, okay, in comment. So when I got 5 ampere, I also coming 5 ampere, means both are coming positive in the directions are current, okay. 5 ampere here, 5 ampere going here, means current in that branch will be what? Then no current will flowing in that branch. Okay, let me check calculations once more if I did something wrong. So I have simplified this equation was 6i, yes, 6i plus 3i and 45, correct only. Here I got 6i minus 9i1. So when I put it here, I subtracted, added and added. So this became 60, that becomes what, 12, and 12 goes what, 5 times, this is correct. So then calculations here, 6i, 9 into 5 is 45, correct only, that's minus 15 also, okay. So 30 coming, okay, everything is coming, okay, means you did calculation correct only. So now listen carefully, current I1 in this branch is 5 ampere, in that branch 5 ampere, means here current was going I minus I1, means no current flowing that branch, 0 ampere, okay, no current flowing this whole branch, okay, because that branch I minus I1 is flowing, okay. Now what they are asking question that what is the current flowing through this branch, this was the only question now. So which is what, BD means what, I1 is flowing, okay. We don't need to calculate actually even this, because question was this much only, that what is the current in this branch, that you already calculated here, what, 5 ampere, okay. Then yes, okay, let's see more questions. Question number 4 and 5, let's see this question first, is looking simple. That I'll solve on top. So look at this 5th question first. Find the potential between G point and H point, okay, open circuit given. So between this point and this point they are asking, and currents are given to you. Look how currents are given. They say 2 ampere here, so 2 ampere coming here, 2 ampere coming at this point, 2 ampere will come, then see this branch and this branch, we need current in this branch. So if you watch carefully here, how much given, 1 ampere means 4 ampere should go like that, right? At this junction, 1 ampere going upward, 3 ampere going downward, means how much current should come at the junction, 4 ampere, means 4 ampere coming here. Look here, how much coming here, 2 ampere, and 4 ampere going, means current should flow in upward direction of what, 2 ampere. So 2 ampere coming here, 2 ampere coming here, at this point 4 ampere will go in this direction, right? So this is the current you found first. Now same rule, currents you know, resistance you know, so start from G point, so VG. Then we going to 4 ohm, we going direction of current, so minus 4 into 2 is what, 8 volt, 4 ohm, 2 ampere. Then plus what, 3, we jumping from negative to positive terminal. Then this resistance, so 2 ampere and 2 ohm, so what, minus 4, we going direction of current. And in this resistance we going against the current. So what is voltage drop here, 2 ampere into 1, so what, plus 2 is equal to what, VH. Okay, so this is your VG minus VH, how much coming, minus 8, minus 4 is minus 12, and this is what, 5 remain, minus 12 and plus 5 is what, minus 7, so what is the answer, 7 volt, that's the answer of this question, okay, simple. Okay, one more question remaining is this one. In the given circuit, if the potential at point A, where is point A? So I did not mention here in this where is point, I forget, right? Some question was asking, suppose this is point A, or okay, doesn't matter, let's call this a point A and this is what, your point B, okay, something, okay, Hanji. So if potential at point A is what, 0, then find the potential at point what, B, okay, something, doesn't matter. So this question was actually, this question is from PYQ and it's very important question. It's very simple also, but it's confusing, so I gave it here. Okay, look here. They ask me the potential difference between these 2 points, obviously again. And if you watch carefully in this question, look here, many things are unknown, like this resistance R unknown, this R2 unknown, this R1 unknown, right? So student get confused that so many things are unknown, current unknown, how will you find them, all of them, okay? You don't need to find, why? Because which rule you use, I told you, you want to find potential difference between 2 points, then it does not depend on path. Any path you can go, you will get the same answer. So you don't need to find anything, all this. You don't need to calculate all resistance. Look here, there are many paths. We are finding potential between these 2 points. You can go this path, then you need this resistances. You go by some path, this path you need resistances. But you follow this path, which path? You go from here to here, then you go here, this path. You don't need anything, all are known to you already. How known? Look here, 2 ampere current is flowing in this branch, 2 ampere comes at this point, and current in this branch given 1 ampere means how much going downward? 1 ampere. So in this branch current we know, all we know, right? Yes. Suppose we start from point A, okay? We starting from what? VA. We starting here, first we got this battery of 2 volts, so plus 2 volt, because we going negative to positive terminal. Then we come to this resistance. This resistance has how much current? 1 ampere and 2 ohm resistance, and we are going downward, so it becomes minus 1 into 2 or 2 into 1. Okay, we came here. Then we came here to what? This battery. It's what? Negative 1 volt. So minus 1 is equal to what? VB. And they said potential at A point is what? 0. Okay, this is given 0. 0 plus 2 minus 1 what? VB. Right now, 2 get what is VB? Minus 1 volt. It's actually PYQ. I did not write this point A and B properly, but similar something was asked. So it may be like A here and B here, doesn't matter. Then answer will be what? Plus 1 volt. Okay. Okay, so we have done a lot of questions on this based on Kirchhoff law. It's very simple. Okay, so you practice this today in exercise 1. Your sheets you have to solve till 1 to 67. All questions will be clear by this time. Okay, 1 to 67. If you have any doubt, please put your comment or message me on WhatsApp. Okay. Okay, thank you so much. This is for today. Thank you.